So in this video, we're going to derive the cosine sum and difference formulas. So those identities are as follows. We've got cosine of alpha minus beta. Alpha and beta, those are just angles, equals the cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. And the cosine sum identity, alpha plus beta, is equal to cosine alpha cosine beta minus sine alpha sine beta. Okay? Now, why is this crazy formula true? So, this is something to add two formulas to your tool belt. So let's kind of go through a proof of why this works the way it works. Okay, so let's take a circle. So let's take a unit circle. Okay, let me make two of these bad boys. All right. Let me throw this over here. Okay. All right, so we've got a unit circle. So right here is at 1, 0. Okay. So what I'm going to do is I'm going to actually prove this one first. Okay. And then I'm going to use that first one to show you how the second one is true. Okay. So for this proof, I'm going to assume that beta is less than alpha, which is less than 2 pi. Now this works for any alpha and beta, but without loss of generality, I'm just going to make these assumptions here. And I'm going to start by putting alpha and beta in the standard position. Okay, so my beta angle is smaller. So I'm going to take my beta and I'm going to go up to here. And so this angle here is beta. Okay. And now I'm going to do the same thing. For alpha, it's going to be a little bit bigger angle. So I'm going to go here. And I'm going to make it come out a little bit larger. Okay, so this distance here, that's alpha. Okay, so it's a little bit bigger than beta. Okay, the intersection here, okay, this point right here, a point on the unit circle, we can find by evaluating the angle at cosine theta and then sine theta, whatever it is. And so this first angle is beta. So we'll call this would be cosine beta, comma, sine beta. That's that point right there. And then this point right here, this is cosine alpha, comma, sine alpha. Okay, so that's what that point is right there. All right. So what I'm looking for, okay, I want to do alpha minus beta, so the bigger angle minus the smaller angle. So what that's going to do, alpha minus beta represents this right here. Okay, so this right here is alpha minus beta. Okay. All right, so that right there is alpha minus beta. All right, so we take the big angle, subtract the B angle, and we get that in between there. And what this does is this creates a distance from here to here. Okay, so this distance from here to here, okay, from this point to this point, all right, that point to that point, that distance D is equal to, well, what's the distance formula say? Okay, so how does the distance formula work? Well, distance formula is x2 minus x1 squared plus y2 minus y1 squared. I'll take the square root of everything. So what are my 2 points? Well, my 2 points are cosine theta, sine theta, and then cosine beta, sine beta. So this distance is equal to square root cosine alpha minus cosine beta squared, the x values, okay, then plus the difference in the y values, sine alpha minus sine beta squared. Okay, close it up. So that's that distance right there. That's that D1. I'm going to call this D1 here. Okay, now here's what I'm going to do with this picture over here. I'm going to redraw it over here, but what I'm changing is I'm going to take this angle here and I'm going to make it in the terminal side. So this is in standard position. Okay, so I get this green angle, alpha minus beta, and I'm going to put it in standard position. So I'm going to start over here, and so this point right here now is 1, 0. Okay, that's 1, 0. And then I rotated it, so maybe it's like this now, okay? All right, so this angle right here is alpha minus beta, okay? So what does that tell me? That tells me this point right here is cosine alpha minus beta, comma sine alpha minus beta, okay? Let me make that just a little bit smaller so it fits. All right. So once again, I'm going to get the distance between those 2 points right there. We'll call that distance D2. Okay. So D2 is equal to what? D2 is going to be equal to, well, the difference between the x's, all right, that's going to be square root cosine alpha minus beta minus 1 all squared plus sine, let me move this so we don't run out of room, okay, alpha minus beta minus 1. I'm sorry, not minus 1, but actually minus 0, the y value, squared, just like that. Okay, now, can I convince you that D1 is equal to D2, right? If we can, then we can set those 2 pieces equal to each other. Now, obviously, if we take some angle, right, and all we're doing to it is we're rotating it, so it's not like we're changing that distance D1 to D2, we're just rotating it, then it makes sense that it would be the same, right? Well, let's think about why these triangles are congruent to each other. Well, if you think back to geometry, way back in, maybe 10th grade, okay, maybe ninth grade, there was this thing called SAS. Now, I'm not talking about how you treated your parents or whoever, right? SAS stands for side, angle, side, okay? So this side is congruent with this side, and then this angle is congruent with that angle, and then this side is congruent with this side here. Therefore, what does that tell us? That tells us that D1 has to be the same as D2. Okay? So, using those properties, we have proven that those are two equal to each other. So all we've got to do now is set those equal to each other, see what we get. So I'm going to set them equal. I've got square root cosine alpha minus cosine beta squared plus sine alpha minus sine beta squared equals square root cosine alpha minus beta minus 1 squared plus sine alpha minus beta minus 0 squared. Okay, now first thing I'm going to do is I'm going to get rid of the square root by squaring both sides. So I'm going to square both sides. Now when you square both sides, you could be potentially introducing extraneous solutions, so always keep that in mind when you're working through your problems. So when I do that, I literally drop out the square roots. So I'm just going to rewrite, I'm going to be lazy here and rewrite it like this. Okay. Now I'm going to work through the math here. So if I square this right here, let's see, what am I going to get? Well, I'm going to get cosine squared alpha minus 2 cosine alpha cosine beta, and then plus cosine squared beta. Okay. Then I'm going to square this out. I'm going to get plus, man, a lot of stuff going on here, right? So sine squared alpha minus 2 sine alpha sine beta minus, actually that's plus sine squared beta. Okay. And all of that is equal to, well, if I multiply this out, what am I going to get? I'm going to get cosine squared alpha minus beta, and then minus 1. So that's minus 2 cosine alpha minus beta, and then plus 1. Okay. And then when I do this, that's just sine squared alpha minus beta. Okay, that 0 goes away and I just square it. All right, so now what I'm going to do is I'm going to use the Pythagorean identity. Look, I can group these two together. Cosine squared alpha plus sine squared alpha equals 1. But also cosine squared beta plus sine squared beta equals 1. That was mighty convenient, because now all these highlighted things here reduce to just 1 plus 1, which is 2. So I get 2, and then what do I have? Minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Okay, so that's what I have simplified here on the left side. And then that's equal to, let's see if we can do anything here. This and this put together, cosine squared alpha minus beta plus sine squared alpha minus beta Well, that's equal to 1 also. Okay, it doesn't matter if the argument's the same and I'm doing the cosine squared of blah plus the sine squared of blah. No matter what that blah is, if it's the same blah, then it's going to add to 1. Okay, so that becomes 1. So I have what? 1 and 1 is 2. So I have 2, and I have minus 2 cosine of alpha minus beta here. Now I'm going to subtract 2 from both sides, so that cancels. So I get minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta equals minus 2 cosine alpha minus beta. Now, last thing I got to do is divide everything by negative 2. And when I do that, I get my desired result. Cosine alpha minus beta equals cosine alpha cosine beta minus sine alpha. Oh, minus and a minus actually make a plus, so that's actually plus sine alpha sine beta. Pretty cool, huh? So that's the formula. Now, the other formula was for cosine alpha plus beta, right? But all we have to do to figure this one out is I literally rewrite the plus as a minus, and then I can use the formula I just proved. And so this is equal to cosine, well, let's see. The negative, this b here goes for that b there and that b there, right? So I have cosine alpha, cosine, and then I put a negative beta, and then plus sine alpha. The alpha didn't change, it's still the same as that alpha up there. And then sine negative beta. Now, what do I know about the negative with even and odd principles? Since cosine is an even function, the cosine of negative beta is the same as the cosine of beta. Okay? And then the sine of negative beta is actually the negative sine of beta. So I picked up the negative factor. So the only difference is instead of adding, I'm actually subtracting that sine alpha sine beta piece. Okay? So this is the sum identity for cosine. Okay? This is the difference identity for cosine. How about that, right? So now we have got those proven. Both are proven, and you can use those to figure out the problem. So with that, let's work just a couple of examples. We'll do 2. So first one, find the exact value of cosine 75 degrees. Find the exact value of cosine 75 degrees. So, cosine 75 degrees. Well, we don't have a formula we know 75 degrees for, but what we do know how to find it for 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, right? So is there a way we can combine what we do know to get 75, whether it be through addition or subtraction, okay? And in fact, I can get 75 if I add 30 degrees and 45 degrees. So I'm going to do cosine of 75 degrees as the cosine of 30 degrees plus 45 degrees. Okay? So the sum identity, what does that tell me? That tells me that the cosine of 75 degrees is equal to the cosine of 45 degrees. the cosine of 30 degrees times the cosine of 45 degrees minus the sine of 30 degrees times the sine of 45 degrees. Okay? Now, if you're having trouble remembering what the degrees are, you can convert to radians if you're more comfortable with radians. This is the cosine of pi over 6 times the cosine of pi over 4 minus the sine of pi over 6 times the sine of pi over 4, right? So what does that equal? Well, this is square root 3 over 2 times square root 2 over 2, and then minus 1/2 times square root 2 over 2. Okay, so when I multiply this out, I'm going to get the square root of 6 over 4 minus the square root of 2 over 4. And so that's your answer, unless you want to simplify, factor out a 1/4, and you have 1/4 times square root 6 minus square root 2. But that's as clean as you can get it. Okay? Let's do one more. So we did a sum here. Let's try a difference one. So find the exact value of cosine of pi over 12. Okay? So pi over 12. All right, so let's think about, what are the ones that we do know? We know 0, we know pi over 6, we know pi over 4, we know pi over 3, we know pi over 2. Heck, we know pi, right? So those are values we do know. Or is there any way that we can get it to add to 1 over 12? Well, one thing that might help is if we convert our values that we do know to have the same denominator as 12. So 0 is still 0, but this would be 2 pi over 12. This would be 3 pi over 12. This would be 4 pi over 12. This would be 6 pi over 12. And that would be 12 pi over 12. Okay? Is there any way that I can combine to just get 1/12? Well, I have a 2/12 and a 3/12, so I'm not going to be able to add to get 1/12, but I can subtract. Okay? So there is a way to subtract. So what I can do is I can subtract these two together, and that's going to get me a value of 1/12. So let's do that. So the cosine of pi over 12 is equal to the cosine of 3 pi over 12 minus 2 pi over 12. Okay? And so what is this? This is the cosine of pi over 4 minus pi over 6. I like to deal with things that I'm more comfortable with. I see that those came right from that right there. Okay? So, and that's the same denominator as what was going on right there. Okay? So what is this equal to? The difference. How does the difference work for us here? Well, it's the cosine of pi over 4 times the cosine of pi over 6 plus, okay, the sine of pi over 4 times the sine of pi over 6. So what does that equal? That's square root 2 over 2 times square root 3 over 2 plus square root 2 over 2 times 1 over 2. When I multiply this out, I get square root 6 over 4 plus square root 2 over 4. And so literally the only thing different between this problem and the one before is instead of a subtraction, I have an addition. And that is the exact answer. Okay? Pretty cool that we can find the exact answer now. We've got better possibilities going on here. So try to figure out the combination that works so that you can get the exact answer. And if you have to just write them out first and then find that same denominator that they used, then that's what you got to do. Okay? All right, good luck.